Okay, welcome to part 2 of our talks on measurements and errors. Part 1, we did previously, it was talking about devices and errors that we get when using devices. So we talked about analog devices, we talked about the least count and the instrument limitation error, and we also talked about digital devices and how they work. You should go back and watch that previous video to get some explanations for some of these terms. So let's talk about another way to estimate errors. So in this example, what I have here is, let's say we've measured a distance or a length of something. And one way to figure out an error is to take the measurement several times. So in this case, let's say for example, we've measured it 6 different times. And the first time we've measured 9 millimeters, the second time we've measured 7, the next time we've measured 6, then 6 again, and then 3 millimeters, and then 5. You see we have this varying numbers here in our measurement. Now, I mean, a difference between the 9 and 3 might seem extreme, but sometimes you might find these large variations. So one way we can estimate an error is to, well, first find the average of these numbers. So the average, or the mean, is given by, it's just the sum over all of our lengths divided by the total number of numbers, which is given by n. So in our case, we add the mean is just, well, it's the 9 plus 7 plus 6 plus 6 plus 3 plus 5. And in fact, that total is just 36. You can double check that. And what you'll find is when you do 36 divided by 6, you get 6 millimeters. Oops, where'd the 6 go? There we go. So the average value, or the mean value, of these measurements is 6. Okay, so what we're interested in is how much each of these measurements here deviates from the average. And so that's what this second column is. We're going to compute the deviation for each of the measurements. So we just take the number, so in the first case we take 9, and we subtract the average value, which was 6. So this gives us 3 millimeters. For the second, it's 7 minus 6 is 1 millimeter. Then we have 6 minus 6, which is 0. Again, we have 6 minus 6, which is 0. 3 minus 6, which is negative 3 millimeters. And 5 minus 6, which is equal to minus 1 millimeter. Okay, so note, if we compute the average of these deviations, well, we can do this in our head. 3 plus 1 is 4, minus 3, which is 1, minus 1, which is 0. So the average value of these deviations is just 0 millimeters. Well, that's not very helpful, because in fact the average of all of these deviations will always equal to 0. So instead of looking at these numbers, what we're going to do is we're going to take the absolute value of these deviations. So we don't have to do much to do that calculation. We can use what we have and just take the absolute value of it. So we have 3 millimeters, 1 millimeter, 0, 0, 3 millimeters, and 3 millimeters. Okay, oops, that last one's not 3, it's 1. My apologies. Okay, so we have 1 millimeter. Now, if we add these up, it's 3 plus 1 is 4, plus 3 is 7, plus 1 is 8. And we have 6 numbers, so 8 over 6 is our average deviation. 8 over 6, or we can write this as 1.67. Is that right? No, that's not right. 1.33 millimeters. Okay, so this number here, the 1.33, is what we call the average deviation, and we can express our measurement. So the measurement D that we're going to use in our calculations is going to be expressed as the average plus or minus the average deviation. So this symbol here, this term here is our average deviation. And so for our example, the distance measured, with whatever it is going to be 6. That's the 6 we have over there, plus or minus 1.33 millimeters. Okay, now in fact we won't actually express it quite like this, but this is a good example of what we're going to expect. We'll talk about how to express our numbers in another video.